yes, as I said, I'm going to tell you a little bit about Stirling and what we're doing here around data science. So probably you've noticed, because you're here listening to a talk about data science, that in recent years, particularly the last 5 and maybe the last 10 years, the quantity of data that has been generated on the planet and collected by people has grown massively. Things like social media and our ability to measure everything from what our car is doing to health statistics being measured by our watch. We're generating and measuring all of this data. And as a data scientist, what we're interested in is using that data to make things better, right? So to make health better, or processes better, or to run finance or marketing better. So the idea that nowadays, lots of decisions that used to be made by instinct or by human decision making are driven now by data. And the companies who are doing really well in this modern age, Google and Facebook and Amazon and so on, they're all driven by collecting data. But it's not just about collecting it, right? It's about storing it, accessing it, and making good analytical use of it. So that's why in recent years, doing things with data has shifted from being, I don't know, maybe 10 years ago, if you had a job like mine, you'd be a statistician, and people weren't terribly excited about being a statistician. But since then, this idea of being a data scientist and having this ability to really make some important changes to the way things happen in the world has become a much more important thing. And so there are a lot more companies who want to hire data scientists, and there are a lot more people who want to have a career as a data scientist. So one of the reasons that there's this sudden massive growth in the number of jobs being advertised for people with data skills is that there are lots of companies who've realized that in order to keep up with the competition, they're going to have to collect and analyze data and use that to improve the way they run their organization. Either they do their business, or they run their hospital, or they compete with their sports team, whatever it is. And that means that there's barely an aspect of human endeavor that is not impacted nowadays by the use and collection of data. So one of the nice things about studying data science is that you're not studying to do a particular job. You're studying to gain a set of skills that will be applicable in a whole host of different kinds of jobs. So I don't know, I guess if you study to be a vet, you're going to be a vet, right? And you pretty much know what you're going to do. But if you study to be a data scientist, well, you might spend maybe your early career in a bank making some money. Then you might be interested in sport and you go and work for a football team for a bit, doing analytics for a sports team or something. Then maybe you think, oh, I'd like to do something useful, and you go and work for a charity and so on. And all of these different career options will use the same set of basic data skills, but to do lots of different and, I hope, very interesting things. So I've had a career that you would now describe as a data science career for 30 years now. And I've worked in, well, actually all of those fields and a bunch of others, doing lots of different things. And it's always been with the same set of skills. And it's always been really interesting and really rewarding. And so now I'm really pleased that lots of people want to learn to become data scientists and have that same set of opportunities that I did. So I said I've had quite a varied career working in data science. I've worked for companies, I've run my own spin-out company and so on. But now I'm in the computer science and mathematics division at the University of Stirling. And we've set a course now to make data science one of the key things that we do. So we've set up a really good network here in Scotland of different organizations that we work with. There's a government organization called the Data Lab, and their role is to try and get the whole country, Scotland, making the best use of possible of data. And they do lots of things. They help our students, they fund some things that we do. And they've really helped make Stirling a central hub for data in Scotland. We're also working with the Scottish Informatics and Computer Science Alliance, who again are another organisation whose role it is to try and help Scotland and its companies and its organisations make the most out of data. And for quite a few years now, we've been doing some really nice work, some really interesting things with a lot of organisations across Scotland, with companies, people like Adobe and HSBC are here in Scotland, and also with things like the National Health Service and so on, and even with some of our national sports teams. So as a division, we're really nicely integrated into the data life of the country that we live in here in Scotland. And because we do all of that, this is a great advantage to our students when they come here. We have lots of good connections. A lot of our students will go off and do projects with companies or external organizations. And of course, there's a good job market here when you're finished. So some of you will want to come here, study, take your skills back home and work there. Some of you maybe would like to come here and stay here. And the visa opportunities for that are improving now. So there's a good chance that you might be able to come here and use the skills that you've learned here to actually stay and work here. Okay, so where is here? Well, there we are in Stirling. So we're pretty much in the middle of Scotland. We're certainly in the middle of the populated part of Scotland. If you go up north of here, it's not too long before it's all forests and mountains and that kind of thing. But around here, we're between the two main cities in the country, that's Glasgow and Edinburgh. We're about an hour from each. So that puts us in a really nice position. It's a little bit more rural here. We're not a massive city. You'll see some pictures of the town in a minute. But we are really close to those big, interesting cities. They're really beautiful cities. Edinburgh in particular is an important historic city and a big tourist attraction as well. So we're a campus university. That means we're not in the city itself. We're in a lovely green park about a quarter of an hour outside the city of Stirling, or less, I guess, if you drive. And you can see from the pictures here, it's a beautiful setting. In fact, I'm looking out of my window at it now, and it's a lovely sunny day. It's a bit breezy, but apart from that, it's very nice. We do get some rain here occasionally, so that means everything's beautifully green. But when you have a nice day and you can sit by the lake there and enjoy a picnic, it really is a beautiful place to live and work and study. Well, so what's it like at Stirling? We're not a massive university. There's about 14,000 students. That's enough to do some interesting things, but still enough to get to know some people. About 10,000 of those are undergraduates and approaching 4,000 of them are postgrads. So that's what you would join, one of those. We have around 1,500 staff, and we're a very outward international looking university. So last year when we counted, there were over 120 different nationalities represented here on campus. And actually 20% of our students are from overseas. So we're very well set up to cater for overseas students. And I'll talk a little bit about some of those things later. We do very well in a number of surveys and questionnaires that various organizations run. I won't read all of these off, you can see them for yourself, but we're over 90% overall satisfaction rate. You've seen a couple of pictures of campus, but actually we're generally considered to be the most beautiful campus in the UK, and actually the 5th nicest campus environment in the world. Some of that's due just to the beautiful setting. Some of it's due to our excellent sports facilities. We're Scotland's University for Sport. We've got a brand new sports centre that they're just finishing now, or they would be if they were allowed to go on campus and finish building it, but that should be ready quite soon, we hope. So it really is a nice place to live. It's a bit like being on holiday. You've got a great swimming pool and great sports facilities. You've got a lovely place to go out and enjoy the fresh air. And then, of course, all of the state-of-the-art teaching and learning that I'll talk about in a minute. These are the main things that most universities would consider to be important: teaching employability, an international outlook, a good set of facilities, and a good inclusive attitude. And in all of those things, we've been awarded 5 stars by the QS World University Rankings in 2020. Okay, so there's the little advert for the university over. What are the courses that we teach? That's the important thing, right? That's why you're here listening to me now. So I'll quite quickly go through our set of data science related courses. And if you want to ask me some questions about what the difference between them looks like, we could do that at the end. So we'll start with the MSc in Artificial Intelligence. This is a new program. We're launching it this year, and it's a very data-driven approach to artificial intelligence. You can see by the list of program contents here. There's maths and stats, there's programming with Python. There's a course on the applications of AI to real world problems, because we know if you study this course, you're going to want to go and have a career in data or in AI. And you'll need to know how the skills that you're gaining on the course fit into organizations. And so this is a course about that. Then there's all the good modern AI stuff: machine learning, computer vision, natural language processing, deep learning, and so on, and a module on optimization. So really, those are the key elements of modern artificial intelligence. And I really don't think, if you wanted to look for an up-to-date AI course, I don't think that there's anything missing from that list there. I'm really quite pleased with the set of things that we've put into it. Okay, the next one, our MSc in Big Data. This is our original Big Data course. This is what started all of the data stuff for Stirling. And we're into our 6th or 7th year now of recruiting for the course. So it's got a bit of a history to it now. You'll see that some of the modules are shared with the AI course, but this one is a bit more about the technologies around data. So we've got things like databases for big data sets, things like MongoDB and Cassandra. You'll also do standard relational databases. Then there's Hadoop and MapReduce, which again is a big data computing framework. And then some of the things in common, things like Python scripting. The data analytics course is about machine learning and data mining. So this one's a bit more of a mix. AI really is about using data to give computers intelligent qualities. And there's some of that in the big data course, but there's also a lot more about the practical technology around actually storing and moving and analyzing and collecting the data. Now we have one rather more applied, or specifically applied, data-driven course, and that's our financial technology, the so-called FinTech course. And you can see from the list of contents there that it's really finance oriented. So there's some good modern technology stuff in there: blockchain, cybersecurity, and so on. There's some of the data courses, data analytics is in there, but there's also a lot of content about finance, right? So about banking, financial apps and open banking. Here you'd learn how to develop a FinTech application. And then the last of the 4 in computing science and mathematics, this is mathematics and data science. And this is some of the AI course, some of the big data course, and an extra set of modules which are more heavily mathematical. So this is designed for people who have probably a degree already in mathematics, or at least a really strong interest and experience in mathematics, but want to get into data science as well. So it's a rather more mathematically oriented approach to things like machine learning and AI. Okay, I'll also mention our MSc in Data Science for Business. This is a collaboration between the management school here at the university and computing science and mathematics. And you can see from the list there that this course is a mixture of some of the content that I've already talked about. So there's Python programming, machine learning, and so on. And some offerings from the management school, things like risk management, project management, strategic management, and so on. Okay, so that's an idea of what it's like here in Stirling. There's a little idea about some of the content of the courses that we teach. But I mentioned at the start that really what's driving the growth in data as a whole, and also for us at Stirling, what's been driving our new emphasis on data science in teaching is the fact that there's huge opportunities for a variety of jobs with the skills that we're teaching. You've probably seen newspaper stories about how artificial intelligence is going to take over lots of people's jobs in the next 20 years, and we'll all have to retrain to be able to do something else. And of course, being one of the people who knows about the artificial intelligence is one of those sets of skills that the new workforce are going to have. So, as I said before, there are lots of things now that once you've got the data skills, you can choose an area to work in. So you might think, I didn't train to work in medicine, but actually, I think I'd quite like to do something particularly now to help in health. And a lot of the work actually around coronavirus, a lot of the work that's been going on is about collecting the data on the virus, how it spreads, on human behavior around it, as well as all of the medical things, and analyzing that data and working out how to use it to get us back to normal as soon as possible. And there will be new things that happen in the world, new types of jobs to do, but many of them in the future are going to be driven by technology, and they're going to be driven by data. And so having these skills will put you in a really good position to be able to get involved in the career field of your choice, and even to be able to jump from one to the other, finance to health to retail and so on, using that same set of skills, but to achieve some very different things. And as I said before, that's kind of how my career has panned out. And I've really enjoyed it. I felt really lucky to be able to work in a number of different industries and do a number of different things, but all building on the one set of skills. So these are just some of the fields that our students go into when they leave. There's banking and marketing. I mentioned sport at the university. We're Scotland's University for Sport. And quite a few of our students have gone on to use their data skills to have a career in sport. So increasingly, data and analytics are very important in high-level professional sport. You'll see things like Wimbledon and the World Cup and so on. The people and the teams that are doing well in that now have big data analytics teams behind them, helping them work out what's the right strategy, how to play best, and so on. And we're doing quite a lot of that at Stirling, and our students are going on to work in that kind of area. Of course, health and medicine is particularly important at the moment, and I've talked a bit about that. Things like engineering, or even things you might not have thought about, like data journalism. There's a whole field of journalism now dedicated to putting together stories based not on going out and interviewing people or investigating in that way, but using data sources to put together stories. Maybe the most famous of those was the Panama Papers from a few years ago. You remember the scandal around the people who are using tax havens. And that was a big data journalism project to piece all of that together. So just one last thing about career paths. I've talked about the different types of work you might do, the different kind of applications to it. but here are a few of the maybe kind of the job titles, the job roles that you might find yourself in. So at one end, there's a very scientific kind of research aspect to data science. And then at the other end, there's the much more applied work that I've already talked about. So depending on what aspect of it you end up getting interested in, you might decide that artificial intelligence or computer vision is really what you're into, or you might find that it's databases or large-scale data storage that fascinates you. So both in terms of application and in terms of the new technologies, there's a really nice broad scope that you could work in. Okay, I think I've probably mentioned most of those now, so we'll just move on. So just finally, I'll talk a little bit about what it's like to come to Stirling and study data. So each of the courses have kind of 30 to 50 students on them. In some of the classes, you'll find there are fewer students than that because we break you out into smaller groups for things like labs and so on. And you'll find in some of the classes actually that they're bigger because things like the data analytics course is shared by a number of other students. So you might find there's maybe up to 100 students in your class. So the students come from all over the world. They're from, some of them have just recently graduated and they're in their early 20s and just setting out. And some of them are coming back to education after maybe 20, 30 years even working and have come back to gain new skills. So there's a great variety of where people are from, what kinds of backgrounds people have. And actually, it's always really interesting to get to know all of the students each year. We have a really nice, social, friendly atmosphere on the course. We'll go out maybe for a drink or go out and do something interesting, go for a walk and so on. So you get to know a new set of people who, although they're very diverse, they all have this kind of common interest in data. And more broadly in Scotland, there is a really blooming Scottish data science scene. There's a really nice community, lots of companies, lots of meetings, lots of opportunities to go and get to know people who have similar, either studying similar courses or have similar interests. So it's not just about coming here, going to your classes, sitting in your room, typing on your computer. It's about getting to know people, building your own network, and working out where you want to go with your life. What kind of career would you like? How can the people that you get to meet during your time here help you make that career work? And what we try to help you with, it's almost as much about that kind of thing, about getting out there, meeting people, building your network, as it is about, learning to program SQL. So that's our approach to it. That's our attitude. You get a year here and we want you really to make the most of it. Okay, so I'll wrap up in a moment just with a few pictures of some students that we've had on the course previously. Every year, this community of Scottish data scientists, there are a variety of competitions and awards and things that they run and opportunities for the students. And we've been lucky, or maybe good enough, to have our students win quite a few of them over the years. I've included a few pictures here. And these are really nice steps up for the careers of these students. Some of these students I can see here actually who are just from 2 or 3 years ago are now already in quite senior roles in companies. One of the things at the moment, because data science skills are still quite rare, a lot of people are interested in it now, a lot of people are studying it, but there still aren't enough people to fill the jobs. So if you go into a company, even if you start in a reasonably junior role, if it's a junior data science role, generally you progress through the company, promotions come faster, you move up more quickly. And quite a lot of our students are already in quite senior roles. Some of them are earning more than me already now, and I only taught them 3 years ago, because this is what companies are looking for. And if you're good, then very quickly you can be moving into a very senior role as a data scientist. Okay, so that's probably enough talking from me. I hope I've told you some of the things that you might be interested in. I can see that there have been some questions already asked and answered. And so I'll shut up for a minute now and let you type in some questions, and we'll have a go at answering them for you. Thank you very much for coming along today. Thank you very much for listening. And I really hope that I might be able to meet some of you in Stirling later on in the year. Thank you.
Great, thank you very much, Kevin. So what I'm going to do then is I'll read out some of the questions that have been put into the Q&A box,
okay,
and then you can answer them. Those of you who've been writing questions in the chat that haven't been answered yet, if you could make sure you put them in the Q&A box so that we can see them. Now, first question is, excuse me, is data science associated to programmer? I think what they're asking is in what way is data science related to programming? Yeah.
There is some programming involved. If you think about programming as at one end, there's building big software systems like, I don't know, Amazon's website or Microsoft Word. And then at the other end of the scale, there's writing 20 lines of code to open a file, read it into something and plot the results or do an analysis. And so we're at that kind of smaller end. The programming language that we predominantly use is one called Python. It's by far the most common and popular programming language for doing data science. So this isn't about software engineering, but a lot of the manipulation of data that you'll do will use, I guess you call it scripting rather than programming. It's putting together short sets of code to get the computer to do whatever it is you're trying to do with the data.
Great. Somebody's asked if you can inspire them as to what the role of data science will be during COVID-19. I think you already touched on that. I don't know if you have anything else.
I mentioned it a bit. One of the nice things that have happened during this is that lots of organizations have published all of the data that they have. So, for example, scientific journals have made all of the articles about COVID freely available for people to download. And people have been downloading them, running things like natural language processing analysis through them. So you can get a computer to read 10,000 journal articles in a day and summarize the main findings for you. So there's this kind of big data community online. There's websites for sharing data about it. There's websites for sharing the results of different trials and so on. And people have stopped whatever they were doing before and downloaded this data and done things like modeling. Well, so across the world, we're all in various stages of lockdown. And the decisions that are being made about can you go out, how long can you go out for, who are you allowed to talk to, and so on. These are all the results of data analysis. They're all the results of computer models that show, well, if we can have one more week, then the number of infections will go to this. And if we have 2 more weeks, it'll go to that, and so on. So actually, at the moment, maybe we're not really thinking about it, but the results of data analysis are really, really dictating how our lives are being lived, right down to, you know, whether we're allowed out of our houses or not.
Yeah, so it's definitely
I don't know how inspirational that is, but
well, it's definitely a very relevant career path.
Well, yeah.
So a question here, is it possible to jump from a biological science degree to a data science master's course? I guess a more general question that will answer a lot of questions that have been posted is, what are the undergraduate degree requirements for these courses?
Yeah, quite. So I'll talk about that. So we look for a numerate degree. So something where you've done either some statistics or some programming. And again, I'm talking about that kind of lower end of the programming scale. So maybe you've used the software package R, for example, and done some stats in that, or you've done a bit of Python, or maybe you've done something like engineering, so you will have done mathematics. Things like biology and those sciences, it kind of depends how much you did with numbers during that degree, but it also depends to a large extent on a level of enthusiasm and demonstrating that this is the jump you want to make. So we have, certainly this year actually, I've got a student who's one of the best students on the course. She did biology undergrad last year, and she hadn't really done much programming before. She was interested in it, and so she taught herself the beginnings of Python over the summer. And really, if you're willing to do that, and you take some online courses, you learn a bit of Python, you do something like that, then at the end of doing that, if you think, that's brilliant, I really enjoyed that, this is what I want to do, and you apply, then that shows that, you know, you've got some enthusiasm for it, and you know that it's something that interests you. And really, let's face it, if you spend the summer trying to teach yourself Python and hate it, then, well, you'd be foolish to then spend your money on a course that made you learn it some more, right? So to some extent, what I'm interested in students is motivation. I'm not saying that, you know, a quick course, watch a couple of YouTube videos and we'll let you in, but that's the kind of main thing. The students who do best aren't necessarily the students that had the most relevant degrees before they started. They're the ones that had the highest level of being excited by the whole thing.
Great.
So if you're not sure if your degree would qualify you or not, then I urge you to apply. You won't just get turned down. If your degree is kind of on the edges of what we might consider to be acceptable, then we'll have a look at your CV, we'll have a look at your personal statement. And that's where your opportunity to say, yes, I did this degree, which isn't really, you know, exactly data or computing, but these are the other things I've done. And this is why I want to study this now. And we do have a lot of students who've come in like that, and they've all been very successful.
Great. We've had a couple of people ask about PhD opportunities at Stirling University. Could you elaborate on those?
Yes, we have a PhD program, like all universities. A good number of our current PhD students, probably 80% of them, are doing data science related PhDs. So it is a major focus of the division. Some of them are quite theoretical, some of them are very much applied, some of them are in collaboration with other organizations or with companies. So we've got a couple at the moment who are looking at food security. We've got one who's doing something to do with using computer vision and artificial intelligence to help blind people. We're creating new technologies to use computer visions to help the blind. So there's a reasonable range of different applications of those things, but quite a lot of them are driven by data. Some of the PhD students that we have now went onto the PhD program directly, having done the big data course. And generally the way that happens is all of our master's courses are exactly a year long. There's 3 semesters. The first 2 semesters are taught, so you sit in classrooms, we teach you how to do things. And then the 3rd semester is a project, which is more about working on your own. You pick some topic, perhaps with a company or an external organization, or just perhaps something you want to do. And you spend 3 months running this project and writing it up as a dissertation. And if you want to do a PhD, then that project is a great opportunity to get the start of some work done so that you can use that to then go into a PhD program, having already shown that you've got something to do with the project that you want to study for your PhD.
Okay, great. People are asking about internship opportunities while studying on some of the courses that you have mentioned. Is that something that Stirling helps people to arrange?
We do. We don't make any guarantees, of course, because we're at the mercy of finding organisations who are willing to offer either internships or some other work-based experience. A reasonable number of our students who want something work-based get something. We do put quite a lot of effort, and we are quite well connected in the Scottish economy. We're quite close to both of the major cities where some of the work takes place. So we're reasonably successful in finding placements for the students who want them. Of course, it's also up to the students. A lot of the time, if it's an internship, there will be an interview process, there'll be selection. The students have to earn the place as well, but certainly the opportunities are there.
Great. Somebody's asking where they can learn more themselves about data science online. Any resources you would recommend, I suppose?
Yes, there's there's a bewildering array of resources. If you go to some of the online providers like Coursera or Udemy, they've all got some kind of introductory data science courses. There's a place called Code Academy, which has a nice Python course which you can take. I think actually probably the easiest thing, rather than recommending a specific course, is to say, if you wanted to learn something online before you came, the main things I'd look at, and there are plenty of free resources for all of these things, I'd look at Python, the programming language, SQL databases, and if you already know about those, one of the databases to look at would be the MongoDB website. They've got some really good educational content there. I can see in the chat somebody's just said W3 Schools is good. W3 Schools is great as a point of reference. It's slightly less structured in terms of helping you work your way through some learning, but once you've got going, W3 Schools are brilliant for helping you along. If you wanted to look up, there's a course called Machine Learning Mastery, which is quite good as well, for some really concrete examples of how to do these things. I could maybe find some links and share them later if we want to do that.
Okay, fantastic. I'm sure that'd be very appreciated. Somebody's asking, are there any conversion courses offered by Stirling? Now, I suppose that might be something that would normally be offered in pre-sessional, but I don't know if that would be available at the moment.
Yes, it depends exactly what they're asking for. So we have pre-sessional both for English language. You can come, well, under normal circumstances, you can come and study English over the summer. And we also have some other pre-sessional courses for some of the skills that you would need. Like all universities, particularly at the moment, we're increasingly putting our own content online. And so I think some of the pre-sessional stuff will move online. But we haven't quite got to the point where we're able to announce those things yet.
Okay, no problem. Somebody's got a specific question regarding using data science to manage rubbish. So I guess they mean environmental uses of data science.
Yes.
In the modern world.
Yes. Well, certainly it is used. I mean, one of the first projects I was ever involved with, actually, it was about analysing the gases that came out of incinerators. So what mix of rubbish went in and what mix of gas came out to try and minimize pollutants. So that's been going on for quite a long time, and increasingly in recycling, things like machine vision is being used to try and automate the process of sorting, recycling. Yeah, there's quite a lot of opportunity for using those things in that and in other. One of the main issues, this isn't so much about refuge, but is trying to reduce the power usage of computing, because it's such a contributor to greenhouse gas that if we can reduce the power our computers use, that would make an important contribution.
Yeah, it would be a very rewarding career path. Somebody's asked you to specify the difference between data science, data mining, and data analysis.
Well, yeah, so a lot of it is fashion. So our big data course is called Big Data because we started designing it in 2012. And at the time, big data was the most common phrase being used. And so we chose that because that's what people were typing into their search engines. Nowadays, it's data science is the phrase. Increasingly, people are using the phrase artificial intelligence. So some of it's just, fashion. I guess inside of that, machine learning, that and data mining, those are both explicitly about using data to extract either results from data or, particularly with machine learning, to train a computer to perform a task rather than programming it yourself. So that's a specific part of data science. That's the art of teaching computers to perform tasks based on data alone. So some of the kind of high level things, so big data, data science, they're just labels that people use and fashions change in the words. Machine learning and data mining are more specific sets of things that we do with data to analyze it and to teach computers to perform certain tasks.
Okay.
That helps maybe.
Somebody has asked, in your opinion, what do you think the most promising department is? And I suppose they mean the most promising field within what you've been discussing today.
Yeah. Promising is a challenge, right? Because we don't know where things are going. Yeah, maybe I'll start with interesting. I think at the moment, things like computer vision and natural language, this is the first time, artificial intelligence has been around for a long time. And this is the first time in its history that computers have started to show human level abilities at things like computer vision. And if you think even 5 years ago, now we've got phones where you can take a picture of something and it tells you what it is, right? You can walk around an art gallery and take pictures of the paintings and get a description of what they were and so on. Everyone's got some kind of voice activated home assistant thing that you can talk to. And it's still early days with them, right? They mishear you. I've got a sat nav in my car that I can talk to and it's terrible. It never understands anything I say. But those things will improve. And I think in a few years from now, rather than your sat nav just, saying, tell me the address, tell me the street, it'll be saying, it'll be just having a normal conversation with you and you'll be able to say, there looks like a bit of a traffic up ahead. Do you think we should leave now? And it says, no, I think we're all right. We could stay on. And you're actually talking to it as if it was another human. So I don't know. For me, it's that kind of blurring of the lines between what it's like to interact with a human and what it's like to interact with a computer.
Yeah, very fascinating. The final question, and most important, I'm sure, is how can they keep in touch with you? What's the best way to contact you if they have any further questions?
I have an email address. That's probably the easiest, particularly at the moment. Now, shall I type it in here, or are you in contact with them all?
Into the chat.
So I'll type it into the chat now to everybody. So this is the short version of it, which is easier to type. Check that's right. Yep. Okay, so they can use that. They can also, so I've talked about all of our data courses. Each of the courses individually has its own program director, and those people, their email addresses are on the prospectus pages. So if you go to the prospectus and you post a question to there, that won't come to me, that will come to whoever it is who runs that particular course. But of course, they'll be able to answer it as well. But if you ask them something about the presentation you've just seen, obviously they haven't seen it. So you can email me about questions like that.
Fantastic. Well, I've also shared a link there for anybody who would like to contact Integrate about making an application. So people can do that as well, or email you directly. That's all of our questions for today. So thank you very much, everybody, for joining us. I hope you enjoyed it, and I hope you have a lovely evening, afternoon, whatever you have going on. Thank you very much.